Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, now we are going to talk about the isomerism that are being exhibited by the alkenes, and we are going to talk about the examples also and various types of the isomers that is being exhibited by alkenes. So let us talk about that. So before understanding that what are the different types of isomerism that are being shown by the alkenes, so it is very essential for us to understand the isomers, that what is actually the isomers. So before understanding, let us understand what is isomerism. So the phenomenon in which the two or more compounds having the same molecular formula but different structural formula are basically known as isomerism, and the compounds that are being showing the isomerism property are basically known as the isomers. So that's the reason that it is very similar to that of the that we have did in the chapter alkane. Even alkane have been classified in various isomers, and it has various isomers when it comes to the having a same molecular formula but having different structural formula. So similar to that of the alkenes are also been showcasing the isomers. So what are the different types of isomers? That is what we are going to discuss about. So isomerism is very easy to understand. The similarly with the way that we have did in the chapter alkane, but now we are going to talk about what are the types of isomerism that are being exhibited or that are being shown by the alkenes. So basically isomers are been divided into two parts. The isomerism are been divided into two parts, that is the structural isomerism and the geometrical isomerism. So the structural isomerisms are further divided into two parts, that is they have a chain isomerism as well as they could have a position isomerism. So these are the two which are showing the structural isomerism. While talking about the geometrical isomerisms are known as cis-trans isomerism, in which there is spatial arrangement of the atoms that are being arranged in a 3D format or in a three-dimension arrangement. So talking about everything is going to be discussed by us. So let us see the first one, that is talking about the structural isomerism. So the name itself suggests that this would have different kind of structure. It would have the same molecular formula but different structural formula, and based on that this are being divided into two parts, that is chain isomerism and position isomerism. So let us understand what is actually chain isomerism, which is a part of structural isomerism. So now talking about the chain isomerism, so the definition of this would be that the isomerism arising due to the difference in carbon chain length. So these are the isomers that are being exhibited or that are being showcased in those molecules that will have the same molecular formula but different structural formula, mainly when it comes to the difference in the carbon chain length. So let me give you an example in this case, so it would be very easy to explain. Suppose if we have a molecular formula, suppose that is C4H8. And since this formula has been obeying the general formula of the alkene, that is CnH2n, so therefore this would result in the formation of alkene itself when we draw the structural formula of this one. So suppose if the first a normal chain, if we would draw for this molecular formula, then this could be written as 4 carbon atoms that would be in a straight chain, and this could be written as, and the double bond could be either at the first position or either at the second position. Suppose in this case, if I have made that the carbon-carbon double bond is present in the second position, or we could say that it has been forming a symmetrical alkene. So in this case, suppose I could fill all the valencies of the carbon, and this is what we have got. So we can draw we can make another structural formula for following this molecular formula, that is C4H8, and that is have the two double bond here, while this would be having CH2, this would be having CH3, and even this would be CH3. So these are the two isomers that we have got, and moreover, if we could see that the total number of carbon atom in this case is basically 4, and the total number of hydrogen atom is basically 8. Similarly, in this case also the total number of carbon atom is 4 and the total number of hydrogen atom are 8. But what is the difference, and what does this makes to be called as the isomers of each other? The reason behind that is the structure. So the structure is mainly the main important reason. That's the reason of which we could say that the two compounds are basically isomers of each other. But when we talk about specifically, then we get to know that there is a difference in the carbon chain also, because this is a straight chain carbon atom that we get, while in this case we could get a branch chain. So that's the reason they are called to be the chain isomers of each other. And in this case, as you could see, there are 4 carbon atoms are in the straight chain. But in this case, when it comes to the IUPAC nomenclature and the numbering also, so we could see that this would be the basically the straight chain carbon atom consisting of 3 carbon atoms. So therefore there is a difference in the chain length. So this is a 4 carbon chain length, while this is the 3 carbon chain length when it comes to the straight long chain. And talking about the name also, talking about isomers doesn't only have the difference in the structural formula, but they also have the difference in the properties. They might be chemical property, they might be physical property. So that is the difference in the isomers that they show. So talking about this to be named as in the IUPAC nomenclature, so suppose this would be named as basically but-2-ene. So this is the name that we could give to the first member that we have drawn in this case. By talking about this structure could be named as, because as we can give the number as this one to be the 1, second, and this is the 3rd carbon atom, and the 2nd carbon atom we could see that a branched CH3 group is been attached. So therefore the name of this will be 2-methyl, and the total number of carbons that are being present in a straight chain is basically 3. So basically it would be called as propene. But the position of carbon-carbon single bond or carbon-carbon double bond, it starts from the carbon number 1. So therefore the name of this would be 2-methyl prop 1-ene. So this is the thing about what we have talked about, the chain isomerism. So this is the difference between the two structures that we have drawn for the chain isomerism, and it's very easy to understand. So now let us talk about, so this was the first type of the structural isomers that we have discussed, that is the chain isomerism. But let us talk about the second type of the structural isomerism that has been exhibited by alkenes, and those are basically position isomers. So what is position isomer? Let us understand the definition. So the isomerism that is arising due to the difference in position of double bonds in the same carbon chain. So only the difference would be the molecular formula would be the same thing, and the difference will be that that will have different structure. And yes, moreover, when we are talking about different structure and when we are specifying about the position isomer, this would give us this kind of an example. So let us understand this one. Suppose if we have, again I am expressing the same example that we have mentioned earlier. So suppose if this is the thing that I am drawing, or that I am making to be called as an example of the position isomer. So suppose this is the first structure that I have drawn for a but-2-ene, and for another example, suppose if I would take, then so this is the second example. So therefore these are the two isomers that I have mentioned over here, and talking about whether they are following the molecular formula same or not. So if we compare this thing, then this is basically the one which consists of 4 carbon atoms, and even the lower one that I have mentioned, even that will consist of 4 carbon atoms. And talking about the hydrogen, the both will have basically 8 hydrogen atoms, as you could see. They both have 8 hydrogen atoms. But what does makes them to be called as the isomer? Because the isomers are the one which will have different structural formula. And more specifying about this thing, then we are talking about position isomers. So as we could see that the carbon-carbon double bond is present on the second position. How? Because if we know the IUPAC nomenclature of alkene, so this would be called as carbon number 1, second, third, and fourth. So in this case, basically the carbon-carbon double bond starts from the second carbon atom, and while in this case, when we are talking about this case, so the IUPAC, according to the IUPAC nomenclature of alkene, so the carbon number 1 will go to that carbon atom, or it will start from that carbon atom where we could receive the carbon-carbon double bond very near to the number, or that could get a very least number. So therefore the number will start from here, 1, 2, 3, and 4. So as we could see that in the first case, that is the carbon-carbon double bond is between the carbon 2 and carbon 3. While in this case, that is the carbon-carbon double bond is between the carbon number 1 and carbon number 2. So that is the reason that the position of the isomers is now being changed, or we could see that there is a difference in this thing. So that's the reason these two are called to be as position isomers. And talking about the name, so it would be very easy to discuss that the name of this would be but-2-ene, while that case, in this case, it would be basically but-1-ene or basically butene. So this makes the to be the isomers of each other, and more specifically they are basically the position isomers of each other. So that's where the structural isomers that we have talked about. So let us move on to the next isomers, that is basically geometrical isomer. So now we are going to discuss about geometrical isomer, that is the second type of the isomerism that has been exhibited by the alkene. So geometrical isomerism, we should know the definition of that. So it says that the isomerism arising due to the difference in spatial arrangement of atoms or group of atoms, and this spatial arrangement are being arranged in 3 dimension. So that is the reason there would be difference in that case also. Even the molecular formula would be the same, and but there would be difference in the spatial arrangement of the atoms, and that's the reason they are called to be the geometrical isomers. And basically the geometrical isomers are divided into 2 parts, that is cis isomer and trans isomer. So therefore the geometrical isomers are being also called as cis trans isomers. So therefore these are the 2 isomers that it has been divided by, that is the cis isomer and one is trans isomer. So now we are going to start about what is cis isomer, and then we will move towards the trans isomer. So talking about the first one, that is cis isomer. So talking about cis isomer, the isomer in which 2 identical atoms or groups of atom that lie on the same side of the double bond are called to be cis isomer. Let me explain you this with an example. Suppose this is the molecule that we have, and in this case, because we know that it is a symmetrical isomer, and moreover we could see that in this case, that is, if we divide the carbon atom, a carbon atom double bond atom in this manner, if we divide this in this manner, then we could see that the 2 groups, that is the CH3 group and again the CH3 group, the both are mean similar group, so they will be on the same side, that is on the lower side, if we talk it about in a 2-dimensional manner. So therefore they would be on the same side. While talking about the another atoms or the other group that are being attached to the carbon-carbon double bond, that is hydrogen, and in this case the hydrogen are on the other side and the both are on the same side. So therefore the reason this molecule is itself, suppose if I name this molecule, then this would be called as basically butene. And more specifically, when we are talking about the position of the carbon-carbon double bond, this would be called as but2ene. But when it comes to the geometrical isomer, then we could see that when we draw, when we arrange those atoms in a spatial arrangement in a 3D dimension or in a 3D arrangement, then we get to know that both the CH3 atoms or both the CH3 molecules, that is the groups, are being on the same side. That is on the lower side, as we could see on the 2D diagram or the 2D page. While in that case when we are talking about the hydrogen are present on the other same side, that is on the upper side when we are talking in a 2D dimension. So in this case, since these 2 groups are on the same side and other 2 atoms or the groups are also in the same side, so therefore this would be called as cis but2ene. So therefore this is a geometrical isomer which represents that this is a cis but2ene. So this is cis isomer, and this isomer will have different property than that of the other isomer that we are going to talk about, that is the other part of the geometrical isomer, that is trans isomer. So in this case, the trans isomer will have, as we can read that on the screen, as you could see, that it is the isomer in which the 2 identical atoms or groups of the atoms lie on the opposite side of the double bond is called as trans isomer. So let me give an example in that case also. Suppose if we have consider the same isomer, that is when we are talking about but2ene, and in this case we will arrange the atom in such a manner, or we have an arrangement in such a manner where we could see that the one group, that is the CH3 group, is being present on the opposite side, as we could see here. So the division would be, suppose from this case, in this manner. So this is the case where the division happened, and where we could see that this CH3 group is being diagonally opposite, if we would say in this manner also. So they are basically diagonally opposite to each other. and even this hydrogen and this hydrogen, they are opposite to each other, and we could see that they are on different that is a different side. The one is on the lower side of the 2D diagram that we have drawn, while on the other CH3 group is on the other side, and that is the reason they are called to be the trans isomer, because the reason behind that is they are present in the opposite side, while in case of the cis isomer, they were present on the same side. So that makes them to be known as trans isomer. But talking about the name of this thing, again, talking about the name of this thing according to the IPC name, so this would be basically butene. But if you specify the position, or if you specify the geometry of this molecule, then this would be found to be trans-butene, and that's the reason the two molecules, that is cis butene and trans butene, the both are having different properties, and yes, they will have the same molecular formula, but that's the reason they are called to be the isomers. And yes, so because of this, we have got to know that there are different kinds of the isomerism that are being exhibited by the alkenes that we have discussed right now. So talking about this cis and trans isomer, these are very new to us, and this would let us to be in a confusion whether which molecule will show cis or trans isomer, or basically geometrical isomer. So for that, we have a question for you. In this thing, what we have to do is we have to showcase that which one of the following molecules that we have. In this case, we have 5 molecules, and in this case, which one would exhibit cis and trans isomer. So talking about the first one, that let us see whether this can show cis isomer, cis and trans isomer or not. So suppose if I draw this molecule, and even though I will write it in a separate manner so as to know that the molecules are being present in a 3D dimension or in a 3D spatial arrangement, but I can't draw in the 2D dimension exact thing, but we could make it to represent like a 3D dimension, which is in this manner. Talking about the first example that we have, we could see that is the carbon-carbon double bond which is present over here. As we could see, that is the carbon-carbon double bond which is present over here, and on one side that is hydrogen, and again a hydrogen atom is been attached over here, while on the other case, or on the side, another hydrogen is been attached, and this group can be called as C2H5. So therefore this would be written as C2H5, and this would be the H. So talking about whether this will show cis isomer or trans isomer or not. So actually this won't show the cis and trans isomer, and in fact this won't show the geometrical isomers also. The reason behind that is if we have got to know that what is the cis isomer and trans isomer definition, then in that we have got to know that that will have the same that will have the group that would be on the either same side or that will be on the opposite side. So talking about the hydrogen, so hydrogen are basically on the opposite side, as we could see, but we can't see. Suppose if we divide in this manner, suppose if you have divided in this manner, so these are the two hydrogen that are been on the opposite side, or in this manner also we could see they are in the opposite side. But what about the C2H5? The C2H5 is on the one side, but on the other side whether C2H5 is there or not, no, there is no C2H5 group present on the other side. So that's the reason this is not to be called as a, or this will not show cis trans isomerism. So that is the reason the first one is not showing the cis trans isomerism. So let us talk about the second one that we have. So this is the second group that we have, and let us see whether even this would show cis trans isomers or not. So for that we can draw the structure as, and in this case the thing that we should do is we should always focus on the carbon-carbon double bond, because this is the only position where we could divide into 2 sections, and that's the reason we will get in this manner, where we have written carbon-carbon double bond over here, and in this side what we have got to know that on one side that is hydrogen and on the other side there is CH3. So suppose in this case, suppose if I draw hydrogen, and on the other side suppose if I draw CH3, and in this case suppose on the other side, as we could see by filling the valency of the other carbon atom, which consists of carbon double bond, one is having a methyl group, and this carbon is basically having 2 methyl groups. So I would say that one side will have CH3 while the other one will also have CH3. So whether this shows cis and trans isomer or not, the answer is no. The reason behind that is, suppose if we divide these two things in two sides. So CH3 is the group that we could get on the opposite side in this manner also. But what about hydrogen? Hydrogen is not present on either this side or either that side. So that is the reason that this will not exhibit cis and trans isomer when it comes to the geometrical isomer. So this is not the correct answer, or let us try with the third one that we have. So this is the third molecule that we have, and let us see whether this will exhibit cis isomer or trans isomer or not. So for that thing, what we have to do is we have to divide, and we have to represent in a geometrical manner where we could see that all the groups are being attached separately in a spatial arrangement. So that would be written as. So we will focus on the carbon-carbon double bond, and we have written over here that is the carbon-carbon double bond, and on one side or on the one valency of the carbon, one hydrogen has been attached, and on other side that is C2H5 has been attached, as we could see here. So this one would have the hydrogen over here, while on the other case it would have C2H5 over here. So this is the one side that we have drawn, and talking about the another one, so again it will have the same thing, that is hydrogen, and the other one will have C2H5. So therefore this could be written as either H in this way and C2H5 over here. So now, can this show cis isomer and trans isomer or not? The answer is yes. This will show cis or either trans isomer. The reason behind that is, suppose if this is the structure that we have drawn, and we have divided in such a manner that we could see that the two groups or two atoms are present on one side. So as we could see that C2H5 and this C2H5, they are present on the one side, and this hydrogen and this hydrogen is present on the other side, and even the same side. So that is the reason, suppose if these two groups are on the same side, that's the reason this would be called as basically cis isomer. This would be cis isomer. So talking about the trans in this thing, so this could be represented in this manner also, where we could write the structure as C2H5 H double bond, and here it would be H, and here it would be C2H5. So in this section where we could see that if we divide in this manner, so there we could see that the ethyl groups are present on the opposite side, and this hydrogen is also present on the opposite side. So it is not necessary that the two will be present on the diagonally opposite. They could present on the opposite side also, like in this manner also. So then also it would be called as basically trans isomer. And more specifically when we are talking about, so they should be at least opposite side of to each other in this manner. Then only it would be said as the trans isomer. And talking about and dividing this section also, suppose if we are dividing in a vertical section in this manner, so this in this case what we could see that the C2H5 and the C2H5 are on this side basically, and the hydrogen are on this side. So even that could be said as the cis isomer. So these are the cis isomer. But talking about specifically about the naming of this thing, then since and moreover we could see that this is a symmetrical molecule, and let us see what would be the name of this thing. So the carbon number 1 and 2 is present over here. This is the third one, 4th, 5th and 6th, calling to be that as a hexene. But the carbon-carbon double bond starts from the carbon number 3, so therefore this would be called as cis hex 3ene, while this would be basically trans hex 3ene. So now this is the one which shows cis and trans isomer. So thank you friends for watching this video. I hope you have understood this video very clearly, and you have also got to know that is what is alkanes and what are the general formula of alkanes, and yes, what are the types of or classification of alkanes that we have studied. So thank you friends for watching this video. Share this video with your friends, and yes, don't forget to subscribe to Ekeeda channel. Thank you so much.